Well, I really didn't want to spend another session, to be honest, doing this Thunderpole T2000. So we're revisiting it because one of the complaints in the original letter was it was deemed too quiet. Now, if you remember, when we looked at the deviation, it was 8 kilohertz, so it's like transmitting on 3 channels at once. So it was so loud, you think, oh, is it so loud that it's actually quiet? And so when we did the on-the-air test, and we go through to the base station, and you can't tell from the base station what the volume of the radio is, because it depends exactly how I've set the volume and how the AGC works on the camcorder. But when Mr. Chippie came back, he said, that radio is a bit quiet. And I thought, but the deviation is spot on. So in fact, it's a mic gain problem. But it's not the radio. I'm absolutely astonished at what I discovered when I opened up the microphone. So here's the microphone. Let's zoom in a bit. It's stacked on top of this Cobra 29 for a reason. And the Cobra 29 was part of another demonstration to somebody else. So, as you probably know, they're not exactly my favourite set. They're probably not anybody's favourite set. They look squished, don't they? But that's where it ends. Is that going to be in focus? I think we've stacked it too high. Put that back. We'll use the Cobra. That's going to be better focus. So, when we look at the other side, there's a small hole, and that small hole is the microphone. So this housing is the same housing that could be used with the speaker microphone. So this bit would be for the speaker. That looks like it's for some LED in some other function, not in this function. And that tiny hole is for the microphone. So when you open the thing up, the last thing you expect to see is this. A microphone. So I kind of looked at it gone out, and when you take the board out, sure enough, there's the microphone that's in that little aperture. So what on earth is this microphone doing? So I disconnected one leg. Did a test with Mr. Chippie. He says, oh, that's too loud. So we're going to have to open the setup and redo the deviation. So I'm glad the customer sent the mic in with this. Goodness knows where he got it from. I thought all this kind of silliness had ended in the 80s. So we've got a dynamic mic that somebody has decided to connect. I don't know whether they thought that this microphone case was empty. What is the logic behind it? So if I get the circuit diagrams, I haven't got a circuit to any of the Thunderpole products, but here's a circuit for the Midland 78. So this part of the circuit shows the electet or condenser microphone, which is of course an old-fashioned word for capacitor. Like people had condensers in cars, but they're capacitors, aren't they? So you have the insert, the little tiny module that I showed you, and then there's a capacitor, there's a 10k resistor, there's a 22k resistor, and it's got up-down controls and something else, just like this Thunderpole, and that's why this was an ideal circuit to show. So what on earth happens if you put another microphone across the pins? So let's look at what Wiki say about electet microphones. I'll just bring the camera out a bit for this one. A bit more than that. probably about there. So what it goes on to say is it is a permanently electrostatically charged device. We don't need to know how they all work. So it doesn't need power. But it goes on to say, however, because they incorporate a built-in field effect transistor as a preamp, because they need a lot of amplification, and so it needs to be at that end or you'd end up with a hum and all that, and noise. It needs a power supply, and it's normally 1.5 volts. So what you'd call probably a bias, or so what does it say here? A typical electret microphone preamp circuit uses a field effect transistor in a common source configuration. The two-terminal electric capsule contains the field effect transistor, which must be externally powered by a supply. The resistor sets the gain and the output impedance. So that's going back to here, what's happening. So where you have the microphone's connector on a radio, there is going to be power going up there. The chances are it's going to be 1.5 volt. I don't need to know how it does it as a service engineer. We only need to worry about that when you find there's no power going up there. I remember having this with some hand portables which have electret microphones. When I was at Nottingham Radio, we had a swine of a job. And could I find the bias voltage for this built-in microphone on a Maxon Apex 520? But eventually I found a 4K7 resistor, which was open circuit or dry joint or something like that. So it is a powered microphone. Now on these kind of sets you can put a dynamic microphone in instead, and it will be wired in such a way that it doesn't short out the 1.5 volt supply. So if you put a dynamic microphone, which I'll now unsolder, and this isn't even, this is clearly out of something else. You can tell it's not a bought-in part, it is out of something. I wonder how many ohms. Well, we haven't got have we got an impedance meter on here? Yes, we have. So it's seeing it as 199 ohms. So what we're doing is putting 199 ohms across here. So effectively we've now got 200 ohms. So if you've got 1.5 volts, this is now, it's not shorting it out, but it's certainly removing a lot of it. So the original microphone is no longer getting its power, so its preamp's not going to work. So now you're relying on, presumably, this. Now, these are polarized. A microphone is polarized, like a speaker's polarized. So you've got a positive and you've got a negative. And one way, the diaphragm's going to move as you speak. It's going to be going inwards. So there is a positive and a negative. So imagine if that's going to be the positive end. So imagine you've got this across there and you've got these opposite way on. But what happens is you end up with a noise cancelling microphone. So if you have two microphone inserts and let's say we've got positive, negative, positive, negative. So what would happen, let me just think about this, you would have these wired probably out of phase. So that would be to your radio. And what would happen is that one would be moving inwards and producing a positive, and the other one would be producing a negative. And you end up with what they call a noise cancelling microphone. So for lorry drivers or for people close speaking, you have a noise cancelling microphone. I think what they've ended up doing is not only they've cancelled out most of the 1.5 volt preamp voltage, I think it's out of phase, and so they've actually generated a noise cancelling microphone which you have to talk very loudly into. So that was absolutely bizarre. Yes, this radio will work on a dynamic microphone, and you can wire it up to the connector in the way which would be normal for the radio, you know. But you can't add it into the existing microphone circuit when there's already a preamplified microphone in there. So I'm going to put this back together, and we'll go through to our base station, and I'm going to compare it with another set. But first of all, I'm going to have to reset. That's come out of something else. There's supposed to be a weight in there, which is now missing. I just find it absolutely bizarre. So I thought I'd show you this. No wonder the guys are struggling with the volume. But actually, I can't say it's a faulty mic. It's a screwdrivered mic, isn't it? So effectively, it's a power mic, isn't it? And I actually took apart another Thunderpole microphone just to make sure it wasn't me who was going absolutely doolally. So I'm going to pause the video, and I'm just going to reset the deviation. Okay, so we've now got the deviation meter showing. So now if I talk into this, testing 1 2, testing 1 2 3, 1 2 1 2 1 2 1 2 1 2. We've got a jolly good average around the 2, and it's peaking at very, very slightly over the 2.5. Testing 1 2 3 4 5 5 4 3 2 1. So what I'm now going to do is I've got this Cobra 29 underneath. So first of all, I'm going to put the base station on. We'll now swap the aerial for test equipment to the actual aerial. I'm going to talk on here, and then we're going to talk on the Cobra. I want to hear what the two sound like. I've no idea how this Cobra is set up, but it's a radio that I set up whenever, I did the video on it. So I know it was right. And we'll see what the volume difference is without changing the volume on the base station. Tango 21 testing the Thunderpole T2000 with the repaired microphone. So it's now on its electet insert. Testing 1 2 3 4 5 5 4 3 2 1. Now we're going to switch over to a different radio. Testing 1 2 3 4 5 5 4 3 2 1 on the Cobra radio. So there you have it. Done it off that Cobra. These are dreadful sets, in my opinion. They're probably the swishiest mobile ever made, but the receiver is so insensitive. I can't think of any other radio that's as insensitive as one of these. But it just happened to be on the top of the pile, and we were using it as a demonstration for somebody else who was concerned that when it switched off, and I'd never noticed this before, when you switch the radio off, and you switch your power supply off, and you switch your power supply back on again, the radio boots up momentarily, even though it's off. That's because its on and off switch is a standby switch. It's not because the radio is faulty. So that's what that was about. So thank you for watching. I hope you found that informative about shorting out condenser microphones by putting an extra insert in, probably out of phase, and then wondering why it's as insensitive to speech as that one was.